Now to start looking at reciprocal functions of, guess what? Yep, quadratics. So the important thing here is let's draw this thing initially. Well, a couple things you got to look at. Number one, x squared minus 9. Let's find out where it equals to 0. Again, you probably have two different ways of doing this. You can say that this is x minus 3, x plus 3, or you can solve it, but either way, you know that x equals to plus or minus 3. There's your critical points at 1, 2, 3 right here, and at 1, 2, 3 right here. Minus 3 and positive 3 become your critical points. And then, of course, we also have to figure out where is our vertex. And our vertex here, you have to remember a couple things. Well, you have to remember your ax minus p squared plus q. And if you realize that your p is actually 0 and your q is actually -9, you know that your vertex is at 0, -9. All right, so we can draw this out way the heck down here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. So our original question looks an awful lot like that. There's our original graph. Now, here's the cool thing. As soon as you flip this and make this 1 over x squared minus 9, guess what this becomes? Yup, those are the values that made it equal to 0. So guess what? Those are the values that are now non-permissible values. And those, in fact, become, guess what? Our equations of our asymptotes. So x cannot equal to plus or minus 3. Our asymptotes then are x equals to 3 and x equals to minus 3. So right at minus 3 and 3, I'm going to put my asymptotes down. There we go. Boom. And right there. Boom. There's our asymptotes. Now, a couple other things that we have to look at here. And I'm going to get rid of this to give me just a bit more room and a little less confusion. Okay, so we're good so far. Now, remember, this was our vertex. And remember what we're going to do is we're going to reciprocal this. So if we reciprocate this, our vertex of our new reciprocal function is just going to be 1 over -9. It's going to be very, very small, negative still, but 1 over -9. How do I know? There's -9. Our new vertex is going to be here at -1/9. Reciprocate it. So what does this mean? Well, this means that you're going to get the flip of this entire graph. This entire graph is going to be flipped. Again, non-permissible values here and here, which gives us our asymptotes. So the other thing we have to kind of calculate then, after we figured out this reciprocal, is this. We have to figure out the invariant points. And the invariant points happen, again, when y equals to plus or minus 1. So let's figure out our invariant points. Woohoo! Here we go. So x squared minus 9, let's let equal to 1, right? X squared equals to 10. Square root of x squared is going to be x equals to, yep, plus or minus about 3.1 or so. Okay, so at 3.1, there's a possible, right there, where we hit y equals to 1 is right on the y equals to 1. So that's about 3.1. That's going to be your invariant point for there. But what happens when we say x squared minus 9 equals to minus 1? Bring that over now. We got x squared equals to 8 and x equaling to about 2.8 or so, plus or minus. Okay, check this out. At 2.8, which is 1, 2.8, which is going to be right about here. There's your invariant point here, and there's your invariant point here, right there. Okay, because of course that's where y equals to minus 1. Those are accurate numbers for your invariant points. All right, so what does this mean? How does this graph look now? Well, this graph looks actually kind of cool. What we're going to do here is we've got this invariant point here. We have this, which is our reciprocal of our vertex, and this is our other invariant point. And remember, being that these are asymptotes, our graph is actually going to do this. It's going to come along this line here, right to this invariant point, and then it's going to start curving towards our vertex, then it's going to hit this point and start curving down. So that is the flip of this. Now, what are we going to do with these guys out here? Exactly what we did with the last question. This is a graph going out this way. So guess what? This is going to come out this way, come up to this point, to the invariant point, and come straight up. Same thing with this guy. It's going to come out this way and come up right there. So again, if you look, our horizontal asymptote, again, is when x equals to, or I should say, my apologies, y equals to 0, but our vertical asymptotes is at x equaling to -3 and x equaling to +3. Now, the scary thing here is, can we do this on a graphing calculator? And the answer to that is, of course we can. Let's take this original graph and let's put it as a reciprocal graph in y1 and see if we come up with something that looks like this. Okay, so here we go. Graphing calculator. We're going to take the reciprocal, which means 1 divided by, and this is where brackets come in. You have to have brackets around this, otherwise it's not going to work, because you want the entire denominator, x squared minus 9. Okay, here we go. Here comes the graph. It's going to look weird. I'm going to tell you right now. Now, what the heck is that? Well, basically what this has done is it's giving you your asymptotes. Right there. There's the x equals to -3. There's the other asymptote at, guess what? X equals to +3. But remember, this calculator is not high definition. So think about this. What does this line mean? Well, this is the line that goes through there and comes up this way. What does this line mean? It's the line that comes through here and goes out this way. But what the heck is this? Well, that's this part, which comes up here and goes like this and comes down like this. These two kind of bouncy things here are, in fact, our vertical asymptotes. So it doesn't look that great on your calculator. It looks an awful lot like this mess right here, but just remember where your vertical asymptotes are and you'll be fine. Probably the best thing you can do is graph the original graph and go from there.